welcome to our Tech Talk podcast, where we cover topics from the industry that are important for infrastructure deployment, testing, maintenance, and we introduce a special guest star. Today we have Nick from HellermannTyton, looking after land systems. Welcome, Nick. And our subject is pathways, the importance of infrastructure pathways, choosing the correct product, often overlooked, but it's so critical. As you add more cables and more products, we need to get that right. Nick, great to see you, mate. So, how do we get started? How do we share the importance of pathways? What are they? Can we describe it to our audience?
Okay, so a pathway or cable management system essentially are solutions or systems that help to manage high volume amounts of cable within the infrastructure of an installation. So this could be something that most people are familiar with, such as basket tray. It could be ladder, or it could be perforated cable tray. But essentially, these items are installed throughout a building, and they are what carry route and direct cables between rooms, between floors, or even between buildings in some circumstances.
Yeah, we see this a lot. Typically, there's different types of basket trays, fibre sort of styles of ducting and plastic. Is anyone better than the other? And which one would you recommend you should deploy when you're choosing a type of pathway?
I mean, it really does depend on what you are installing. But if we take specifically a data center environment, for example, in that environment, you're going to have a high volume amount of fiber cables being deployed. Now, in that kind of environment or scenario, you would typically opt to install something like a fiber duct. So at HellermannTyton, we've got a system called GigaDuct.
Okay.
It's a noticeable yellow ducting system. And what that actually helps you to do is completely segregate all the fiber cabling away from other services such as power, any other type of building management service control solutions, data cabling or copper-based data cabling. So Cat6a, for example.
Oh, okay.
Which would typically run on your metallic cable management solutions.
Okay, so I'm just reading that back for our audience. So these types of products contain our cable infrastructure that grows over time. There's different types. There's wire basket, this molded plastic styles of ducts, and they're used to separate this thing. I must admit, why we're sharing this subject today is the problem is as if infrastructure grows over time, and we see more and more cables going into these ducts and bundles. So the critical element is, and why you need to know this is we start getting pinch points. Are you seeing these problems with pinch points where cables are stressed as they add more and more services to a building? And I was just thinking things like hospitals, if you can think of those, universities, which have over the time aged, and there's more and more cables just spilling out of these ducts.
Yeah.
So could you just shed a bit more light on? So there's wire basket. Would you put fiber optic cabling into that, or would you put that into? When do you choose?
Yes, so there's nothing wrong with using basket tray, for example, to actually lay your fiber cables, and that's quite standard within an enterprise scenario. So again, obviously you've mentioned hospitals or maybe universities, and obviously we look at those installations as more typical enterprise structured cabling environments. So in those environments, the use of fiber is going to be fairly minimal.
Okay.
Yeah. So you may be running single cables of fiber up a riser to feed each floor, and then predominantly it's going to be copper running along the horizontal. However, if we look at something like a data center,
okay, can I just share that to our audience? So just to explain that, so just a few cables, which we call a riser, would be going up the building. So that's between floors. Whereas when we talk about a horizontal, can you just explain that? That's typically at our level, isn't it? The area we're looking around.
Yeah, so horizontal is just a typical term used in the industry to describe the cabling that actually runs out along the floor. Okay, so in an office like this, where we've got multiple levels, Each level will be fed by a fibre cable or a backbone cable, okay? And then from there, obviously, we take the fibres we need to service each floor, and then that fibre medium is then transferred over to copper cabling. And it's that copper cabling that actually feeds the rest of the floor. So when you come into your office and you sit down and you plug your laptop in using your RJ45 patch cord, that is linking you to that horizontal cabling, which is going back to your telecoms room.
So there's multiple types of duct required. Is this planned as you grow, or planned from the start, or do you add it as you grow?
Typically, most of this stuff should be designed from day one. Okay, so when the ITC, the architectural design, is being done, what should be taken into account really is any future expansion, moves, adds, and changes.
I just got to jump in there. For the waiters, Nick had this big dry grin on his face, because that was a loaded question. He and I see this all the time. Whenever we go out, that it's almost impossible to plan for expansion. There is a rule. What's the rule on ducting?
For cable pathways specifically, you are supposed to design in or have pathways with a capacity that will allow you to install at least 30% on day one.
Okay.
So the fill ratio of that duct or cable management system should be no more than 30% from day one. And that gives you obviously 60% for expansion, potentially.
However, how often have we seen that tactic deployed efficiently? It's a tough one, because things change in buildings, and designers may not consider the recent advent of how important infrastructure, communication data centers have become to us. So here we go. How often have we seen problems with one cable pathway chosen?
Yep.
Electrical cables, very often added into pathways.
I think one of the main problems from that perspective is not only looking into the expansion that you might require in the future, which is obviously very, very difficult to determine, but if we focus solely on, say, the Ethernet twisted pair cabling, so Cat6, Cat6A, you actually have to separate those from power as well. And most of the time, the containment, those cables are sharing the same containment. So as well as future expansion, you need to also allow for separate power and data separation as well.
Can we share a bit more on that? So particularly, specifically, copper cables must be separated, yes? So what can we share today?
Yeah, there is a general calculation that most ITC design architecture should use, okay? And it's to do with the type of containment being used, okay? Whether it's basket, perforated, or solid metal, for example. What type of copper Ethernet cabling is being used? Is it Cat6? Is it Cat6A? And obviously they run at very different frequencies. So 250 megahertz for Cat6, 500 megahertz for Cat6A. Okay, so Cat6A carries a much higher frequency. Whether the cable is shielded or unshielded, and then what the power cabling factor is as well. So actually, how many power cabling circuits are running, single phase, 3-phase, what the voltage is, all that sort of stuff. So there's quite a lot to actually consider.
Who would make these decisions? Who would you find? Where is the pressure for the right person to say, this is what I'm doing with this piece of infrastructure, and I need to have it in place right from the start?
From a structured cabling perspective, it is typically the ITC design consultant that can actually be responsible for that. By the time it gets to the installation, it's not really the installer's remit to,
Okay.
Yeah, it should be designed in place by the time it gets to the installation.
So it's so good to see you and to chat like this. I mean, I really enjoy these conversations, because we see this time and time again. This is where pathways, cabling infrastructure kind of creates pinch points.
Yeah.
So it may not necessarily mean your system fails to operate, but what it does start building in problematic pinch points, degradation in future speeds, and it reduces the length and life of your cabling infrastructure.
Yeah, absolutely.
Things like waterfalls. Would you agree? How would we describe a pinch point to our listeners?
I mean, it does work both like for both copper and fiber. So a lot of the time I see issues, well, within my experience, I've seen many issues related to copper cabling. Okay. So with pinch points on copper cabling, it could be something as simple as the cables are running over a basket tray.
Yeah.
Okay. And as we know, the basket tray has these periodical runs. Okay. And if you've got a large amount of, say, Cat6A cable bundles running over those cables at the bottom of that bundle are being squashed and squeezed against these runs. So these are really the pinch points. The best analogy I normally use when I'm running training sessions is to think of your garden hose. Okay, so you're outside, you've got your hose, you turn your hose on. So the hose represents the cable. The water that comes out of that hose is the data transmission. You start to squeeze that hose and you'll start to see a drop off of that water pressure.
Okay.
So it's the same analogy, and effectively the same thing is happening with with copper cable.
Yeah. So I see the same thing as well. It's weight. I mean, we forget the copper cable bundles as you add them over time actually are quite heavy, and the particular points of pinch points that you're talking about are typically the bars which go across the lateral bars across to create wire basket, and they put individual pressure points across those series of cables. The challenge is we pick that up in testing. You can see that as reflections in your copper cable, and over time that does create degradation of performance. But what I see in fiber often is how you enter into a rack. I mean, I'm sure that's this is sometimes a forgotten thing. I'm coming out of the roof on pick a point anywhere you can think of that there's a frame somewhere in a building called a rack where they put all your important equipment. And this cable just somehow comes out of the ceiling and into it. And we need something called a waterfall to take some of those pinch points away. But I see this time again, Nick, that they kind of don't take the stress point of that fiber out and it starts kinking. And then we put heavier items on that cable. And this is where we have problems with our infrastructure.
Yeah. So specifically with fiber, and a lot of people probably don't realize this, you do still have the same issues as you do with copper. So you still have the pinch points and you still have to be concerned with the bend radius of that cable. Now, we know within the fiber standards that there are various types of fiber to help manage different types of bend radiuses. So what you really do need to do is when you are transitioning from a cable run and you are, say, dropping into a cabinet, and say there is a mass of fiber cable, so that's quite weighted, is you do need to protect that bend radius as much as possible.
Yeah.
And ultimately, without that, you are going to see a reduced performance from day one, and you will see degradation over the lifetime of that system as well.
Totally agree. Another one is, and we often forget about this. So for those involved with infrastructure, welcome. It's lovely to have these podcasts to share this information with you. But the often forgotten thing is we steal an excess fiber. And where does that go? Like we have to put the fiber somewhere. And this is where our pathways get choked, don't they?
Yeah.
Because where do you put that little bit of excess? Can you share any of the rules around what to do with your extra piece of cable when you're deploying these systems?
You would normally have some form of fiber loop storage. It's as simple as that.
It's like a J run, isn't it?
Yeah, so you need to, the best way I normally describe it is trying to lose that excess somewhere.
Yeah.
What you don't want to see is it coiled up underneath cabinets or on top of cabinets or anything like that, but building a proper system and solution to actually help steal that fiber loop. So in the case of if we use a product like the HellermannTyton GigaDuct, actually what you can do is use extra bends to actually create a fiber loop storage as part of that cable management system. Or you can have products that look like 19-inch mounted panels, for example, and you can bring fiber in there and actually store looped fiber within that.
what are you finding in the industry? Are a lot of people following these guidelines and deploying them properly?
For the most part, I would say yes, but with any type of industry in the world, no matter what it is, there's always some problem somewhere.
Yeah, I say it's got to do with sites specific to sites. So, for example, for legacy buildings such as, again, going back to hospitals,
Yeah.
schools, which have grown over time, particularly railway utilities, their need for cabling has increased. However, their pathways kind of haven't.
Yeah.
So we find these problems that storing service loops becomes really, really difficult. So we should really share what is a service loop. A service loop is a little bit of extra cable should you need to re-terminate that item again. And roughly how much would you say would be in a copper service loop? How much would you recommend?
We normally just say you need enough excess cable at either end, so at the work area outlet end or within the telecoms room by the panel, to essentially have enough to do at least 2 re-terminations.
Oh,
As minimum. So, that could be a meter or 2, roughly speaking.
okay. So this is a challenge. So you can imagine there's these pathways, there's this ducting, and we're adding more cable, more infrastructure, and you've got to somehow store this cable right where all of these problems can occur. So one, you're transitioning in from a roof into a rack. That's a challenge. You're then trying to terminate it all in an area. And this is why, of course, we need testing. This is why we need infrastructure design.
Yeah.
And we need to consider our product of choice. So we're just leading towards, you mentioned the gigaduct system. Wow, it looks kind of amazing. I'm just going to pick up a piece of the gigaduct here. And it's very, very much a purpose-built plastic mold with, looks like a very simple to fit lid that I've not seen these in action installed myself. How easy do they go together?
This, I mean, firstly, it's a really simple duct. Okay, technically speaking, as you've already described it, it's a nice. I mean, this straight length is an extruded UL 94V0 radius, low smoke zero halogen thermoplastic. And this is purely designed to house fiber cables in a data center.
It's got a lovely feel on it too, so a nice finish.
And our particular product is actually designed to be very quick and easy to install. In fact, it's actually one of the quickest ones to install on the market.
Time saving is important.
Time saving is very important, especially in the data center world, and especially in today's data center market, where look at the amount of growth that's going on in the data centers. They're expanding and they're being built very, very quickly to actually cope with today's demands. So something like this, our gigaduct product uses a tool-free coupler.
Okay.
So back in the day, you would have a coupler and you would have a bunch of nuts and bolts, and you'd have to sit there and put your holes in and screw everything together. So it's very, very time consuming. Something like this is just snaps on.
Wow, that was quick.
Well, you've got with other ends here, for example, and obviously just line that up, snap it in, and that's it. It's as quick as that. No tools, no drilling, nothing like that. And if you did make a mistake, or in the future you went to add on because you are expanding as a data center, the flexibility and the scalability, again, comes down to this coupler. It's as simple as taking that on, and then maybe popping on a transition point.
So we got a trumpet here. Is a example of a waterfall where we have a purpose built. Is that right? Bend radius.
So a trumpet, something like this. This is like a little add-on accessory. So this is obviously a different size to this example like here. But if I had an end piece and I wanted to actually drop some fiber off the end here, I might sit on a trumpet.
Oh, could you show me how quickly that would fit? That's really interesting. What is it? That's a means of adding a waterfall as well.
So, there are many systems out there in the data center space that require you to actually, when you want to make a transition off the main route, and you are going to create a drop into, say, a cabinet, for example, a lot of the systems will require you to actually cut the side walls off. the gigaduct from HellermannTyton is purely based on these tool-free waterfalls. Okay, so effectively, these just pop onto the ends like this. Okay, we've got an end and legs. Okay, and then we just flip these little parts down, and it locks into place.
Wow.
So number one,
That was quick.
yeah, very quick. So again, just like the 2-3 cup jar, the idea is no nuts and bolts, very quick. The beauty of something like this, and this is where it adds to the flexibility of the solution. I haven't cut any holes into the side of the wall here.
Okay.
I need to move this. I'm moving cables. I'm putting in a different cabinet down here. I can simply unhook this and move it around, and I can maintain this. I don't need to replace the straight length because it's now got a massive hole.
So I'm just going to read this back to our listeners. So once again, thank you so much for joining us. What we have is this beautiful purpose-built piece of plastic ducting, molded ducting, which has lips on each side. The idea is you can now, without the need to drill and join it, is a snap-in-place joiner. And that's just a very, very simple slotted joiner, which goes between each duct. The other thing to describe is, we're talking about a waterfall. So if you can imagine in your mind what a waterfall looks like, as in a true waterfall, it's a gentle bend where water would go out. We have this in front of us in the gigaduct. So it's a duct with a cover and, of course, a nice gentle bend radius, allowing cables to come out of that when it connects to other areas. Because you can imagine, as we bring more cables into buildings and we have multiple racks, how to feed to those racks, isn't it? It's difficult. And people overlook that. So we start having them come in all directions. This can keep it contained and allow a point of distribution.
Yeah, it helps with reorganization, essentially. So organization, protection of your cables, and obviously helping to manage a bend radius, but also expanding very, very easily through the functionality of the actual product itself. What can typically happen if somebody isn't using something like a waterfall or a trumpet to support that bend radius, if they are dropping fiber cables off there, essentially you're dropping off a very sharp edge. If you imagine a cliff, okay, so you've used a waterfall scenario.
Yeah.
Let's imagine a real life cliff, and you're just dropping a cable off there. You've got quite an acute angle that cable is being pulled out, especially if you've got a bundle of those cables.
Yeah.
So what we're trying to avoid there is that very sharp angle at that drop point at all. And what we'll need to do is make sure we maintain the correct bend radius. And it's not just to make things look pretty and organized. It is essential for the performance of that cabling. Okay, so with fiber, we have things called macro and micro bending, and that is where the fiber cable can essentially be overbent.
Yeah.
Okay, and what happens there is you've got that light signal that can, in some cases, bleed out. Okay, so from your perspective, you will have something called a visual fault locator, which will actually highlight where these bleed outs happen. Okay, but also just to help, maintain that signal integrity.
Yeah, but still got a lot. So we see reflectance. It's not only is it a challenge, we need sometimes specialist equipment such as OTDRs, so optical time reflectometers, to start picking up where these pressure points are. So we then have to start adding or introducing higher levels of testing to identify these pinch points. So it is a challenge. We need to design it properly in the first place.
Yeah.
And may I say, old buddy, pretty good on the tools, mate.
Yeah. I'm not an expert. There's a lot of great installers out there, but we like to design products that makes their life as easy as possible.
Moving on to question of the week, where our viewers get to ask a question of us across our range of social media platforms, which we hope you're enjoying the wealth of various types of media that we do. But now we get to use one of those questions and chat with our guest. Nick, our question is, what are the different types of data centers?
That's a very good question, Gordon.
How did you see it? I mean, how could you explain the different types?
We can make it as complicated or as simple as you like. I like to keep things nice and simple when we're doing training and actually talking to customers. So the various different types you might hear about are enterprise, colo or co-location, hyperscalers or edge data centers. These are really the main sort of types. So what are they? An enterprise data center tends to be a data center that is wholly owned by a specific business. So, for example, a nationwide or international supermarket will likely have their own data center, which means that they own the land or the assets, the equipment, and they run and manage all of that, okay? Which means that they have a lot more control over what happens with that data center, expansion, etc. But it could be more costly because they've got all of that asset and land to actually manage. The next one would be a co-location, or some people refer to as a colo for short. These are basically data centers that control their own infrastructure to a certain degree, okay, but they rent the space out. So again, very applicable to public or private sectors.
So who would they rent that to? So for colo, we're saying they're renting space out?
Yeah, so rather than, if you're an enterprise, for example, and you don't have the means to actually, or the requirement to that respect, to actually own your own data center, and you just want to buy some space, okay, then co-location data centers, they're like the Blockbuster of data centers. They're there to hire and rent out space for you.
Right.
Okay. The next one would be a hyperscaler, which is a big one in our industry. These would be run by the likes of Google, Meta, Microsoft. So these guys are handling a huge amount of data. They are building AI. They're handling big data. They're renting out cloud-based services to everybody and anybody globally. So they need a vast amount of connections. They take a vast amount of power. They are being run globally. So absolutely low latency, high powered, very large data centers. And the reason why they include hyperscalers is because they need to have the ability to scale their business up to meet the demand very quickly. So we know that today, with Netflix, gaming, 8K TV, all this sort of stuff, Wi-Fi, cloud storage, the more and more of that demand that grows year on year, the larger the hyperscalers need to be able to keep up and grow with that demand.
And when we consider testing across those types of products, for us, we typically see data center testing is straightforward certification. How do you see it?
Yes, the same. So for us, we offer a 25-year warranty for our connectivity solutions. Okay, so whether it's copper or fiber, and that to actually qualify for that, number one, it needs to be installed by an authorized installer. Okay, which means that they're familiar with our products and how we want them to be installed. And then they need to use a industry recognized certification tester. So something like the LANTech 4, for example, and they need to run a fiber certification test. And what that will do is actually show us against the industry standards, like an ISO or a BSEN standard, that those fiber cables are actually forming in accordance to those standards.
Great, straightforward, isn't it? So a lot of people do talk about OTDRing as well in these data centers. It's important, but they're purpose design, some of them short runs, in-phase testing. How do you feel about all those other elements?
OTDR testing is important, but from a warranty perspective, it's not the type of testing that typically us as HellermannTyton or any other manufacturer really would accept, because it's not a certification testing. Obviously, end-face cleaning and end-face inspection really should be done, okay? And as part of any training, we would obviously train people to make sure that they are doing end-face inspection, cleaning, and then inspecting again before they connect.
Yeah.
And the reason for that is you can get contamination on the end faces, and actually it's a very, very high percent contamination does.
Yeah. Until glass gets dirty, doesn't it? Yeah, it's so easy.
Yeah, so I was just trying to say, I'll less more words there, but basically, yeah, it's a very simple thing to do. I mean, it's been ongoing in the industry for years and years and years, and you tend to find that there is still very little in terms of protocol on-site where testing, inspection, and cleaning is actually done to fibre cabling and end faces. And unfortunately, the contamination of fibre end faces is responsible for quite a high percentage of failures or disconnections or low latency runs. So for something so simple that still isn't done as a whole in the industry, would solve many, many problems.
I'll tell you what, Nick, let's invite you back. How about we cover that subject in a future podcast, and we'll talk about some of the connectivity in data centers and faces. Connecting to it. How about that? And I think our audience would love to know more. But right now, we're going to wrap up. So, look, thank you for joining us today. That was wonderful. So you got to hear about the different types of data centers, what are the challenges when you work with them, pathways, the importance of pathways. So please keep in touch. To all our viewers out there, please do comment on the social media platform. And please, we'll look forward to see you again.
Wish yours did that? Time to go blue.